Impressive. What you're looking at is the closest star, Sunspot 2818. It's grown in the past 24 hours. Now we've got multiple umbrae, carbon production, and that's what you're looking at here, actually. This is the 1600 angstroms SDO wavelength. And you're looking at the UV emissions of ionized carbon. What's interesting about this is that at the point of the umbra, where it appears dark right here, you see very little carbon. And look at the area between these newly forming umbrae. Right here, see this white region? That's a lot of carbon. So, carbon being fused, being formed right before your very eyes there, folks. You're seeing a lot of carbon emerge from a very small amount of carbon. How about them apples? That and lots more on today's Daily Space Weather, including a nearly 100% chance of coronal mass ejection, and more about the growth of that sunspot. It's a major uptick here at the Smash News Network, least busted name in news. And here's some more data for you. And I would remind our viewers that we have date stamps on practically all the data that we show on the channel. So now you're looking at the solar magnetogram, and you can see the additional magnetic organization there ahead of Sunspot 2818. Now moving into the range of a beta-class sunspot, increasing the likelihood of significant solar flares, adding to the possibility of coronal mass ejection. So now we're out at stereo A. If you're wondering where it's located at Lagrangian point 5, the gravitational equilibrium point that trails the Earth in orbit. So the Earth orbits in this way, folks. And stereo A follows the Earth. The Sun rotates faster than the Earth orbits it. Takes about 28 days for the Sun to complete a Carrington rotation. 27 days, 28 days. And that's where Lagrange point 5 is located. So here's stereo A, and you can see significant coronal projections of plasma here. Again, the likelihood of a coronal mass ejection now nearly at 100%. We'll let you know when it happens, now that we've let you know before it happens. So here's a full disk view again, and I would note to our viewers that carbon is very interesting. We're looking at a bunch of carbon emitting ultraviolet radiation here from the surface of the local star. Notice the way we see a lot of carbon appearing around areas of extreme magnetic organization, such as sunspots. Continuing on, here is a colorized magnetogram along with 171 angstroms. This is just in the SDO browse data, folks. You can easily bring this up yourself. Just head to the SDO page, click on Data, click on AIA/HMI Browse Data, and you'll be able to bring that up quite easily. 171 angstroms plus colorized magnetogram. A great display of solar activity. Here's another wavelength. This is 193 angstroms by itself. This is one of the great wavelengths for observing coronal holes. We do indeed have a coronal hole. We also have a geomagnetic storm forecast by NOAA, so lots of stuff to cover today. So let's blast through a bunch of more information here. Here's a chart of the solar system. There's where things will be in a week. Again, note the date stamps, folks. Note the date stamps. Here's a star chart, and the sun just rose when we were about to start recording the video today. Also, you should see Mercury and Venus, if you could see those planets in the daytime. If you're up before dawn, you may see Jupiter and Saturn rising ahead of the sun. Radio flux is only at 74, actually, right now, folks. I'm sorry, 77. The radio flux is 77. Solar flux units, here's a one-year chart of that. And we're expecting a precipitous uptick to continue to go on with the radio flux. The red line here is the sunspot number. And so here's the geomagnetic storm that's forecasted, and this is interesting in that their own coronal mass ejection model doesn't necessarily really match up with their warning, but that's okay because, hey, what you got to do is you got to over-forecast when it comes to things like this, the same way snow forecasters over-forecast snow and flood forecasters over-forecast floods. NOAA has over-forecasted this coronal mass ejection strike a little bit, calling for a G2 class geomagnetic storm and a KP of 6 on April 25th. So there's that data. Here is their model of the ejection, and it doesn't really, in my opinion, match up very well with what we saw or the geomagnetic storm forecast. But right here is the coronal mass ejection. You can see the way it's propagating to the east of the Earth. In other words, in this direction. And anyway, that's NOAA's forecast. Ours is for a less direct impact than that. But in any case, that's NOAA's forecast. Next, looking at earthquakes. And we saw at least one over a 6 magnitude here, and it was at depth near Tonga. Let's scroll up the list. Also a deep quake at the Philippines, one at Japan. And we're just going to let the list scroll here, citing anything out of the ordinary. Here's another deep quake at Tonga. So that's actually a foreshock. I believe it was a 6.5 that happened there. So there you go, a 6.5 at Tonga. That one happening at over 300 kilometers depth, estimated depth of that quake. And if that was at the surface, that would be like an 8 magnitude quake, folks. So that is a significant quake there, right in between Tonga and Fiji, in the deep quake capital of the world, Oceania. Continuing on, a deep quake at Chile also. And a deep quake at Indonesia and in the Aleutian Islands, a 5.0 magnitude quake out there in the Rat Islands. Yes, the Rat Islands. Alrighty. Here at the Smash News Network, we also talk about volcanoes, so let's get to it. Smash News Network least busted. Name in news. Okay, so Mount Abico has also been erupting. It's producing an 11,000-foot ash plume. Sakurajima, 9,000-foot ash plume there. Suwanosejima, 4,000-foot ash plume there. 14,000-foot ash plume at Sinabung. Sinabung on the Isle of Sumatra in the country of Indonesia. Semeru, also in Indonesia on East Java, erupting 13,000-foot ash plume there. Dakono, 7,000-foot ash plume on Halmahera. Fuego in Guatemala, 16,000-foot ash plume as it explodes. Sangay, volcanic ash not observed. Please don't square dance around the caldera, and thanks to our viewers who leave comments about caldera activities, don't cast a baby into the caldera to sacrifice it to the volcano gods. Revenador exploding in Ecuador, 15,000-foot ash plume there, and we're unable to detect whether or not Sabancaya is erupting, which brings me to our public service message. We say it daily. Please do not pole vault the caldera. Now, I'm about to order some socks. If you want to know about pole vaulting the caldera, head to smashamash.com. You can find our social media links there, as well as links to our stores. This one is the smAsho merch store, but you can also find the forum there. If you'd like to win a free month of May Patreon at the $3 tier, sign up for the slam poetry contest. All you got to do is submit a slam poem, and you might win. One free month of Patreon at smashamash.com/forum. And here, oh, you've caught me shopping, folks. I'm about to pick up 3 pairs of the Do Not Pole Vault the Caldera socks. Again, you can link to that right on our homepage, smashamash.com. Smashamash.org will redirect you. Have you unfollowed us on Twitter? Well, we've lost 3 followers in the past couple of days. Cheers. Congratulations. If you're on Twitter, I don't know, follow us, unfollow us. I frankly don't really care because social media is fully pathetic. Allow me to vanish allow me to vanish and make the Smash News Network vanish as well as soon as we get a counteroffer. Anyway, here's the GOES X-ray flux, and we just saw a geomagnetic storm condition happen here just before midnight. And we saw a C-class solar flare erupt as well. Peak flux was right around 23:20, so 20 after 11 universal time, the peak flux of that C-class solar flare, which trailed off quite promptly afterwards. The geomagnetic storm was not caused by that. It was actually caused by magnetic stimuli, which happened to come through at the same moment. No strikes in the proton flux. Not yet. And I'm not expecting any even when the geomagnetic storm comes, if it does, from the coronal mass ejection as forecasted by NOAA. Here's the GOES magnetometer over the past 3 days, and the geomagnetic storm was caused by this moment right here. This sudden drop-off of magnetism created magnetic pulses here on planet Earth. Geomagnetic pulses. We'll show you that momentarily. First, a view of the heliospheric current sheet. And I believe Earth is already in the North Pole-oriented current sheet here, although it is currently showing us just about to snap across. You can see the Earth's potential field surface source line right here in orange. Still showing in the South Pole current sheet. I wouldn't be surprised to see that already in the North Pole current sheet. And this is not an immediate thing all the time, folks. And that does explain these sawtooth patterns here and this sudden drop-off in the GOES magnetometer. So here's another view of the current sheet. This is like a three-dimensional view from the line of sight. It also shows you the solar magnetogram. We like the graphics. We show it daily on the channel right now. Here's the line of sight coronal hole plot, which also shows you the sun's B field in blue. And there is a North Pole-oriented coronal hole rotating in. You can see, oh, it looks like it may have filled in. So maybe there is no more North Pole-oriented coronal hole. But we see an uptick in sunspots. So here is the uptick in sunspots. You can see Sunspot 2018 briefly making it into beta-gamma classification there as those new leading umbrae formed. We're talking about this area right here. And also massive numbers of filaments. So we've got filaments down here, we've got filaments up here, filaments on the northwest, filaments all around the eastern limb and around the south polar region. Filaments galore. Likelihood of coronal mass ejection nearly 100%. Here is global geomagnetism, a measurement known as the KP index. And you can see that brief moment of geomagnetic storm there. A KP of 5 was achieved just by that precipitous drop-off of magnetism. Here is the real-time solar wind, which we also show daily here at the Smash News Network. Least busted, name and news. And there's the real-time solar wind. Current data is, by the way, we also saw a phi angle shift happen around that moment. And a bit of a shift in the BTBZ, but not particularly major. Anyway, current conditions of solar wind are about 8 protons per cubic centimeter for the density and about just under 460 kilometers per second for the solar wind speed. Here is 4 hours of magnetohydrodynamic pressure model as modeled by the Space Weather Modeling Framework. And we'll advance that to where it was when it annoyingly refreshed while we recorded the video. There's approximately 4 contiguous hours there. And here is 4 hours of geospace delta B. In other words, changes in the Earth's B field. We keep all the magnetic data in the same section of the videos, folks. You're going to see some major perturbations here, some major changes to the Earth's B field here, measured in nanotesla. South of South America. So less so at the South Geomagnetic Pole, which is someplace down here by my pointer. And moving on to more data. But first, let's welcome our viewers from Twitch. So twitch.tv/smashamash is our primary live streaming platform, although we do make live streams on YouTube as well. And we can't wait for BitChute to include live streaming and playlists and other features on its platform. But in any case, There is exclusive content there, such as our video about hydroxychloroquine, which we released on March 19th of 2020, if you're wondering. And yeah, so thanks to our subscribers over there on BitChute. Again, check out the exclusive content if you haven't. Some of it's redundant content that you can also find at youtube.com/smashamash. Again, twitch.tv/smashamash is a fantastic live streaming platform. If you haven't pressed like and subscribe on YouTube, please do so if you're new here. And don't forget to tell your friends and foes about the channel. Nobody else is doing it. And we've barely even just begun to create content. Content such as our cosmology segments. So today's cosmology segment is so jam-packed full of stuff that we're going to have to blast through, starting out with the astronomy photo of the day. And this one is of SpaceX and the plume created by the spacecraft as 4 astronauts were delivered to the International Space Station. I played it a second time, so you can all freak out about how it's geoengineering. Next, looking at the speed of stellar rotations. Were you aware that there is a relationship between the way the fields behave on stars and their rotational speed? Well, it's a known thing. We've covered it before in the cosmology segments. If you haven't checked out our other cosmology segments, check out youtube.com/smashamash/playlists. As we've talked about this, as stars have 2 sets of fields. So you've got the poloidal fields, which are where the north and south poles of the stars are located. And then you've got the toroidal field, which is a donut-shaped field that goes around their equator in most cases. That field is the extent to which the poloidal fields overlap each other. We call it the sun's B field. And these fields are directly related to the rotational speed of the star. So, without getting super in-depth into this, this is a paper about weakened magnetic braking supported by astroseismic rotation rates of Kepler dwarfs. But the point is, folks, that all stars are variable stars. And we know very little about stellar life cycles. Astroseismology is one of the emerging frontiers. And rotation rates are related to magnetic fields. So if you see the sun's rotation rate changing, that's pretty important. We'll be on top of it. Here's another story. By the way, that one was from phys.org in the astronomy and space section. Here's another one about a tidal event. So a tidal event, folks, is what happens when a star and its orbit and rotation and so on affect another star and its orbit and rotation. Sometimes this happens around a supermassive radio source located at a place like perhaps a galactic core, or even a less massive radio source, like what you would refer to as a medium mass black hole. We'll just refer to it as a medium mass massive radio source. But it looks like we may be seeing the silhouette of a spaghettified star. So, of course, if a thing like a star gets too close to a much more massive object, you could have it start to break into a thread, a filament, etc. A quote, "The researchers know the black hole is facing them from its pole because they detect its X-rays. The accretion disk is only part of a black hole system that emits this type of radiation. If they were looking edge on, they wouldn't see the accretion disk's X-rays. Moreover, the absorption lines are narrow," says lead author Giacomo Canizzaro. "They're not broadened by the Doppler effect like you'd expect when you'd be looking at a rotating disk." So that's another phys.org article. Here's another one about the sun's effects on the Earth's magnetosphere. We talk about this all the time on the channel in the form of direct data. I don't think we really have to spend a whole lot of time on this one, but it's yet another phys.org article, the effects of solar flares on Earth's magnetosphere. So we see induced magnetism as a result of this and all kinds of other things as solar protons rain down on the magnetosphere. While past studies have gathered substantial evidence of the effects that solar wind can have on Earth's magnetosphere, the impact of solar flares is poorly understood. Solar flares are highly explosive events that can last from a few minutes to hours and be detected using X-rays for optical devices. So they're only talking about the radiation here, folks. And of course, we do see things like changes in the deabsorption region of the ionosphere as a result of incoming X-rays. Here's a quote. We demonstrated that solar flare effects extend throughout the geospace via electrodynamic coupling and are not limited to, as previously believed, to the atmospheric region where radiation energy is absorbed. Due to similar solar magnetosphere-ionosphere coupling process in other Earth-like planets, our study also provides new clues for exploring and understanding the effects of solar flares on other planets. In my future research, I plan to study the effects of flares on planets with the same magnetosphere, such as Jupiter, Venus, and Saturn. So perhaps have a read on that, again, in the phys.org's Astronomy and Space section, the solar flares effects on magnetospheres. Today's random number is 108. We're picking one between 1 and 1031 to coincide with an object at the Neil Gorell Swift-Bat X-ray Observatory. 108 coincides with quasar B0317 plus 183, a BL Lacertae object, a type of galaxy with an active galactic nucleus where one of the fields is pointed directly at you. So if you've got a spiral galaxy, folks, here's your spiral galaxy. And if you're looking perfectly perpendicular to that disk, you're probably looking down the poloidal field. And if you're looking down the poloidal field, viewing the galaxy from the side, it might look like this. Just a cigar shape. But you would have these field jets coming out in this direction. And if you're located inside of this field jet, it may be a quasar or a blazar and so on. This one, a BL Lacertae object, is an X-ray emission source. There you can see the historic X-ray data from that. Let's check it out on Sinbad. And it's looking pretty dim. It's probably a distant quasar, folks. You can see how dim it appears. Let's check it out on the Chandra. How about the Multi-Mirror Project? Not showing up there either. How about on the 2MASS? Does it show up in infrared? And indeed it does. And there's your, quote, random and quote object of the day, quasar B0317 plus 18. And let's close things out with two more stories. Here's some current cosmic ray data. As here at the Smash News Network, we prefer for you to have objective data, not a bunch of nonsensical BS about things like cosmic rays. So here is the Apatity and Barentsburg neutron monitor data. So at Apatity, we see an uptick here over the past 30 days. And at Barentsburg, we see a slight downtick over the past 30 days, but mostly flat, a slight downtick. Next, we'll go farther south to Athens, Greece. Here's the Athens neutron monitor. Small downtick in the past 30 days at Athens. How about Mexico City, even farther south? Pretty flat on the past 30 days at Mexico City. And we'll also check Oulu, Finland, and then go as far south as we can get to two Antarctican monitors. So there's Oulu, Finland. Small uptrend over the past 30 days at Oulu. DOMC Antarctica, pretty flat over the past 30 days, and DOMB Antarctica, similarly flat, almost the same graph there, at a slightly different amplitude at DOMB and DOMC. Last but not least, how about AG Carinae, an ultra-hot star with a stellar wind probably somewhere in the realm of 10 times the solar wind speed and density. AG Carinae recently featured here in some NOAA photography, so some fantastic imagery there of this star. And this halo around this star is like nearly 5 light years in diameter. You'll find this all over the Science Wire today as well. The hot giant star, one of the brightest in the Milky Way galaxy, AG Carinae. I'll let the article scroll and then I'll play SciTech Daily's animation. It's pretty well conceived. And this type of luminous blue variable is believed to be near the, quote, end of its life cycle, end quote. Do we truly understand stellar life cycles, though, folks? That's the question that I have for you. Do we truly understand stellar life cycles? Have we ever seen a star born or die? Leave us a comment. Let us know what you think. So here's A.G. Coronal, and I'll just play a little clip of this to encourage you to check out the SciTech Daily article. Fantastic view of this. And you're looking at multiple wavelengths there. Yowzers. Stunning imagery. And here's a bit of a close-up of the halo. Look at the box-like shape. Look at the box-like shape. You can see these like 90-degree angle-looking areas also. Very interesting. And the likelihood of a jet directed away from you is also visible there. So some absolutely incredible imagery. It does look like there is a jet back in the... hey, stop that. All right, I apologize. Anyway, check out the article. It's on scitechdaily.com, and that's today's cosmology segment. We'll have to say goodbye to Twitch, and we'll return for the meteorology segment. And meanwhile, let's continue on with the Daily Space Weather video. The main product here at the Smash News Network, least busted name in news. Here's the electron flux over the past year, and we've seen a little break in the electron storm we've been having. Here is the 3-day chart of the electron flux, and you can see we were well into warning levels the past 2 days. This was something like 15 times warning levels there. And what this is measuring is electron density. Charging hazards are fairly minimal. So there are the charging hazards. They're all minor, but they are on both sides of the equator. Here is the forecast model for the greater than or equal to 2 mega electron volt, greater than 2 mega electron volt electron flux. And that is the green boxes are the forecast, the yellow diamonds are the observation. Here's a diagram of the Van Allen belts, which are largely surrounded by electrons. And here's a visualization of the total electron content forecast. Van Allen belts are looking a little more organized here, although we see anomalies once again over the Atlantic Ocean and Africa at nighttime. So you can see right in here some pretty anomalous levels of electron flux here at nighttime. And for you new viewers, this will show you where GPS errors are likely to occur as it communicates through a lot of electrons, especially around the equator at noon. Here's another diagram of the atmosphere. This is showing you the penetration of electromagnetic radiation, something we've already brought up in the episode. But we're mainly showing it for this F. Are you F'd? Do you know where the F layer is? Well, here's the F ionosphere layer. It's located at about 300 kilometers altitude. And here's a visualization of it. I'll sit back and let this play. Ionosphere looking pretty normal to me. What say you? There's the latest image from 11 o'clock Universal Time. Pardon our lateness. And since we've moved into the realm of meteorology, let's welcome back our Twitch viewers. Twitch.tv/smAsho. If you're viewing this anyplace else, you may want to subscribe over there. They've got a great mobile app which will alert you when we go live on Twitch. I don't know if you were aware. But the next segment of today's Daily Space Weather video is the meteorology segment. So once again, we're looking at the North Atlantic and these areas of extremely calm winds surrounded by some pretty powerful winds like this low pressure off of the coast of Portugal. Check it out. Significant low there. And let's look at the jet stream. And you can see an input all the way up to the jet stream with that counterclockwise rotation off the coast of Portugal. Let's zoom out. And there are the jet streams of the Western world. Quite chaotic in the Northern Hemisphere. Less so in the south, but also quite meridional in nature down there. In other words, going north and south instead of west to east, the normal flow of the jet stream. By the way, these jet stream flows are what are responsible for all kinds of extreme weather around the world, folks. If you weren't aware of this, when the jet stream blows north and south, it can inject very cold air or very hot air at latitudes that are not expecting the very cold or very hot air to be there. Here are the surface winds of the eastern world. And it looks like this cyclonic system has calmed down a little bit. But there is another one up there in the North Pacific. We've got some terrestrial lightning in the U.S. Check it out. It's a very strong lightning storm there. South of Montgomery, Alabama. So here we are. We're on lightningmaps.org. And look at the concentration of lightning here. Lightningmaps.org is where I go when I hear thunder. So massive thunderstorm here. We'll have to show close-ups of this system. In any case, here's your global lightning map. Next, the pressure map. We're going to advance this into the GFS forecast for tomorrow. Here's the GFS forecast for pressure at 12 noon Eastern Daylight Time tomorrow. And if you're wondering where we're located because you're a new viewer, we're located right about there in Lehigh Valley, Pennsylvania. And thanks for tuning in if you're a new viewer. Cheers. Congratulations on actually finding our channel. Here's the weather.gov map. And we've seen the freeze warnings finally chill out. We're going to get some warmer air here in Pennsylvania today. I believe the forecast high is for the mid-60s. A little bit more seasonal. Next, we're looking at the jet stream forecast here on Tropical Tidbits. This is the 250 hectopascal winds. Actually, this is in millibars, but it's the same thing. 250 millibar winds. And so there's the current state of affairs roughly at 12 o'clock Universal Time on April 24th. And it looks like we're getting some extreme cold being pulled down into all the way down to Texas, West Texas, that is, coming soon. Continuing on to look at the U.S. Doppler radar map. And there you can see those extreme storms in southern Alabama. We'll actually zoom in on this location for once. We don't usually zoom in on the radar map, but due to the power of this thunderstorm here. So this one, that amount of lightning could be associated with things like damaging hail, heavy winds, and possible tornadoes. Also another strong band of storms here just moving into western Mississippi. And it's actually swirling up to the north a little bit there, as you can see. Montgomery may still get hit. And we'll also zoom in on this area on the cloud map. We'll zoom in right at the edge of the Florida Panhandle here and the water vapor map to give folks a little better idea of the direction. So here's the cloud layer, folks. And here's the water vapor map. We'll rock that back and forth and go back to the radar as well. So there's the radar. Should give you some idea of the storm track. And this portion of the storm right here is training a little bit, which means it's going to strike the same area in multiple points of the storm. And keep in mind, folks, in the northern hemisphere, the northwest corner tends to be the most likely spot for a tornado to be spawned. So I highly recommend you use the lightning maps, though. Lightning maps really does help you out when it comes to, real-time lightning maps. Real-time lightning maps really do help you out, and they can actually save your life for real. As if you're right in one of those strong cells where there's lots of lightning happening, get inside, figure out some way to mitigate your lightning risk. Anyway, again, there's the cloud layer, and here's the water vapor. And this dry mass of air trailing these storms is going to push things through pretty quickly. There may be a slight turn to the north from those systems. And that's today's meteorology segment. We'll have to say goodbye to Twitch. See ya, Twitch. And it's time to continue on with the daily space weather, with our bonus features, which are current imagery of from the El Teide, Spain Solar Observatory, part of the National Sunspot Observatory. And you can see these massive filaments down here around the southern polar region, as well as some up north. And you can see the Sunspot 2818 as well on there. Great views of that. Thanks to the Smash team. Thanks to our patrons, by the way, also. Patreon.com/smashamash for all the earliest updates, etc. And here comes some more bonus features. It's going to be in the form of the colorized magnetogram and the solar intensitygram. And you can see the way this Sunspot 2818 has grown. Check it out. Significant umbral development on the leading portion. Likelihood of solar flares has gone up precipitously as a result of this. Also expect an upcoming increase in the radio flux. Likelihood of coronal mass ejections is still nearly 100%, folks. Here's a full disk view in 304 angstroms. And you can see some filamentary movement up here, actually. And so what's going on right now is very unstable. We're expecting to see a sunspot at any moment on the Earth side as well as the non-Earth side of the sun. We'll keep you posted as to how Earth-directed it may or may not be. Here is a close-up of all three of the active regions, which are forming a triangle on the Earth-facing portion of the disk. We apologize for any unnecessary fear that may have caused. As we know, people are very frightened of shapes. You could also see a parallelogram forming if you include Sunspot 2817, which has just set over the northwestern limb. And how about 171 angstroms to close things out? And there you have it. In any case, thanks for tuning in, folks. Remember, stare at the sun, attempt to understand the physics, don't drink it. If you do, don't drive. I don't really care if you drink, just don't drink and drive. Seriously. Don't drive. Don't drive, period. And I've been your host, Dan, a.k.a. smAsho, your pro driver, who is signing off, welcoming you to the Neo-Renaissance, and reminding you that since it'll never be now again, may that solar wind be at your back.